everyone. Welcome to Documentation Not Included, a tech industry podcast presented by DNI Stream, the live knowledge repository for software professionals. Ta-da! I did it. It's Thursday, 7 p.m. British time. We are live on twitch.tv/DNI Stream. I am Josey Howarth, and as always, I am joined by the man whose beard has grown more epic than I think I have ever had the chance to see in my connections and time with him, Chris Seabach.
It's getting out of control. I was looking in the mirror today, and I've got this one little bit that I play with all day, and it just will not control itself. And I'm not going to be able to get it cut either. I don't trust my wife with a pair of scissors, so no chance. But anyway, yes. So
hello, my husband's hair.
Hello, Josey, and hello to everybody in Twitch chat. Please do get involved. This is a live show, so we will take comments during the show. You may get a mention. You may even get a little pop-up if you're lucky, because we've got a new little tool to do that. And before we get going, let me introduce our guest today, Zain Daniyal. Danielle? I've probably said that wrong, even though I've asked you just before the show.
That is correct.
Okay. So, hello, Zain. Please do introduce yourself to our listeners and tell everybody who you are, what you do.
Yeah, I'm a data strategy consultant. I do basically sort of contracting and have multiple clients. So, yeah, I'm basically in the artificial intelligence space and data, and working with clouds. So clouds as in Azure, GCP, and AWS, not another clouds
like
that you...
Cumulonimbus, other fantastic cloud names.
Well, only the three, because it just gets... well, now there are quite a few, actually. So, but I think that it's best to kind of focus on the main ones.
Yeah, if it's any consolation, I tend to just stick to Azure these days. I do know a little bit of GCP and AWS, but I tend to just stick to yeah, I kind of come from a Microsoft background, so that's where I kind of stick, put my
I find GCP quite nice. It's just really serverless. It takes, although now I've seen, Azure SQL Server is also rolling out its serverless option. But I just find it's just nicer to work with for certain things, at least for analyzing big data, and then doing all the joint statements and stuff.
Yeah. So before we get into any detail, which I'm sure we'll get into plenty.
Yes, it's icebreaker time. This is a random question that we ask before every show, and it's always a random question because it's just a chance to get to know ourselves, our hosts, and our guests a little bit better. So here's our question for you today. You have just been put into witness protection. What would you like your new name to be, and where do you want to live?
Well, I know where...
Incredibly random.
I know where I want to live, and that's in a log cabin somewhere very remote, well away from computers and everything, technology and everything. Because I might as well, if I've got nothing to keep me here anymore, just go for it, Live naked in a wood somewhere.
And yes, Mike, this is also a question for the chat. So if you have any name that you might want or place you want to be.
And name-wise, I've got no idea. Go on, Zain.
I can't think of anything.
You know where you want to be? Where, live?
I think I would definitely prefer, something similar to Chris, something remote and nice. But I wouldn't want it to be so disconnected that it's just too far from. You can't. I would prefer internet connection still.
I'm with you there. I mean, I say that's idealistic in terms of. I'd love to just disconnect, but I also really love what I do, and I also really love coding, and I enjoy creating things on my computer, because I don't just use my computer for writing code and doing my work. I use it for entertainment. I use it for so many different things. Chatting to my friends, even when we aren't quarantined. I use it for talking to my friends that are all over the country, all over the world, in fact. So I use it for this. This is a hobby / kind of professional, but it's important to me. But there's something about just disconnecting.
Yeah.
See, for me, I would just move to a different country. I'd probably end up in Canada. I am so simple. But as to roughly about my name, I don't know. But I kind of like the idea of something like Madam like Zelda or something crazy or weird or something like that, where I could be that crazy cat lady and I would build a new name for myself as this slightly absurdist kind of neighbor. And I would like put up garden gnomes or something that is completely antithesis to me. Like I see a garden gnome now and I just want to kick them. They're so annoying to me, but I would embrace the idea of that neighbor you talk about. The one that is just weird, who's always got like fresh cookies and bread and, stuff like that. But she's just that little bit weird, that little bit touched. I'd embrace that. But yeah, so that's me.
I think name-wise, I don't know why, Harry just springs to mind. I want to call myself Harry something. But when I was a kid, I wanted to be called Mike. So maybe Mike.
It's funny you say that because Mike, one of our live watchers, has said, I want to be Mike the Liar and place somewhere no one would look for me. So obviously in a place like Skyrim, right?
Up a tree.
Up a tree.
Yeah. In the sky with you. Yeah. Anyway, right. Let's move on.
Yes, to the topic.
Yes, so we're going to be broaching into a subject that I know very little about today. Now, I know about it and on the kind of the outside. I know a little bit about how it works and how it's evolved over the years, and I know a lot about the kind of chaos theory surrounding it, or the potential future of dangers of the future of it. So we're going to be talking about artificial intelligence today, which people who are watching the show can already see that down in the bottom left-hand side of the screen. So we're going to start with a question, because Zain is our resident AI expert. He's come here to talk about
a lot more than we do.
Hopefully.
Oh, yeah.
And I'm hoping I'm going to learn a lot as well today. I'm hoping I'm going to learn a lot about how to do certain things, or what the use cases are for it. Because the things that I do on a day-to-day basis, I put systems together, and I sometimes need to work with, well, a lot of the time I need to work with large amounts of data, and I need to work with machine learning, but usually somebody else has already done a lot of that work, and I'm kind of using the output of it in some way, shape, or form. So
can I just jump in here, because I think this is really worth a distinction. We've had a comment about Skynet in chat already. Now, Zain, how many times have you say I'm involved in AI and people mention Skynet and Terminator to you? Frequently, right?
Yeah.
And
quite a lot, yeah. We can talk about that as well.
But yet, what I find fascinating is when I hear AI, it is not about the Skynet and the computers and things like that. It's more about building algorithms that have very specific, unique purposes that do incredible things. So, for example, a lot of startups we've, built an AI that works in figuring out the best way to handle the pressure of water versus this particular liquid inside ballast tanks on a ship. Like, there's some different types of AI. So, defining AI between Skynet versus practical use might be a good way to start.
Sure. Yeah. I think that's a great way to start, actually. So the thing is that you have, obviously, we all see movies, and there are great movies out there. The thing is that and there are communities out there who are trying to build this thing called artificial general intelligence, that it will generally do everything what we may imagine, and they are trying to work towards it. But as you just mentioned, Josey, that we need focus, and it is the sort of thing that what we'll see in the future, in the recent future, and in the future, in the near future, going forwards, is that it's basically those small, focused, practical applications that will be, that where AI is being used. So I would say that think of AI is a bit like a machine, or just like another machine, how you would think of like a grinder. So imagine, you're living in times when there was no grinder, and the only way you grind things is basically you push, with a very heavy stick or something to onto a stone, and you're basically grinding. But then all of a sudden you have electricity, and you have a machine which is basically grinding. And it's a simple thing. It's basically AI, or the technology behind AI would be used for things which are practical, small, and something that it can do really, really well for that particular small purpose. And we'll just use that in a lot of different aspects, in a lot of different applications. So one of them being currently, facial recognition technology. And with the current technology, in terms of the AI algorithms, as well as the availability of algorithms for the open public, and the tools such as the GPUs available, you can easily purchase, and many of them have been, are used for gaming purposes normally. The combination of these two is basically something which has allowed for technology such as the facial recognition to be much, much better. And that's basically a small niche thing. And that's all it's supposed to do.
So it's not designed to say, make your coffee and then help you decide how to solve world hunger. Its entire purpose is a very driven, specific task.
It might be to make you coffee.
Well, there are groups. Exactly. Tultepe brings up an interesting question. He says that for me, the first thing that comes to mind is machine learning. But he's not certain if that's the same thing.
So there are different things. So machine learning is just a branch of artificial intelligence, and that's to do with, and even machine learning has a lot of branches within it. And outside of machine learning, there are other things which I would say some of them may have already mastered in terms of programming wise. We have already done them. We can already program them, and they're easily available on GitHub. And some of them are basically something too advanced that we cannot do right now with current technology. That includes algorithms available, as well as, say, the limitation of computational power, so GPUs or CPUs. And one of them is basically actually designing, say, if you want to go from one place to another, there are algorithms in terms of how do you structure your flight plan, or how do you structure your travel plan, or what are the different steps you need to do. Certain things like that, although they can be done with, you have, for example, Google, you can actually just plan. But there are certain algorithms out there which are much more advanced, and it's simply not possible right now. So machine learning is a very small branch, and it is, and I can actually talk about, in fact, it's probably a good time to talk about machine learning, as in why is it machine learning that has got famous all of a sudden, or in the current boom at least, and not the other branches.
Can we define machine learning? Because, I mean, I've heard the term a lot. I broadly know what it is, but I don't really know where I would use it. Off the top of my head, as a system architect, I wouldn't know when it would be applicable within a particular system. So if there's so many different types of systems.
Yeah, sure. I think defining would be difficult, but I can definitely give you where you would use it, or in the sense that how where it differs from data or normal data, right? That we can start with. So the thing is that, for example, if you have a problem where if you are, say, you have a lot of data, you probably do deal with a lot of data, very big SQL databases, and you can do a lot of things in terms of joining the different tables, and you can answer a lot of questions just by basically simply manipulating data, manipulating queries. However, for example, if you are working on a problem, I'll give an example. You have drainage data. So you have drainage data in terms of if the pipe is clean or how dirty it is, and what do you expect it to? How do you measure that condition of the pipes or the drainage? And then you have, say, another source of data. You have data in terms of when the pipe was full, and how often. So yeah, how often does it seem to get full? Because you have, say, data of like a transactional. Say, the pipe was full here on this day. It got full again. It got full, and then it was, say, with all the data transactions you actually have in terms of quite detailed information, which is say it was 7% full or 50% full or things like that, right? You have quite detailed data. And then you have another piece of data. You have, say, weather data. Obviously, it rains and it got full because of the rain or something happened. Now, the thing is, how do you put them together to say, can we solve this problem in a way that we have weather data, we know that it rained, and we have data of when and how much the drainage pipes were full and how much they were full when they were full. And we also have the condition of the pipes and the condition of the drainage, if they're dirty or clean, and how much water there was already. Can we kind of form a relationship, or can we solve this question using all the tools available? And that by that I only mean say SQL queries, or just putting together. Is there any sort of join you could do?
Yeah.
The thing, that's sort of problem you cannot do. That sort of problem you have to basically solve using building some sort of an equation in terms of relationship between the water, how much water, or how much rain are we expecting, and how much water should we expect in the flooding hotspots based on the condition of the pipes. Now that's a relationship of say just three different variables, and you are attaching some sort of a number, some sort of a number that, you know what, in this particular area, or if for this particular pipe, so in this particular area, we expect 2 times as much compared to the other area. That if it rains, then it's 2 times as likely because the pipe condition is not clean, or something else is stuck where the pipe meets other pipes, things like that. So that's sort of a relationship that you want to form, and that cannot be done by the normal methods of joining tables or.
Can it not be done because of the sheer amount of data? Is that what we're talking about here? Because there's so much data available, or because it's real time? Because what you've explained to me.
Both really, yeah.
Okay.
So, for example, for it to be accurate enough, and for it to be I'll give an example. But yeah, basically sheer data as well as streaming, or for it to be accurate enough, how can we be sure? How much can we be sure that this is? We know that this will work. So another example is, I guess you guys are aware of how computer vision was done in the 2000 and 1990s.
We're old enough.
You have C++. You have C++ imaging engines, right? So, for example, if you have an image of a cat, the way you would detect this is a cat compared to from a dog is you would say, you know what, we should expect whiskers, and we should expect whiskers based on, we'll say this is the shape of the face, and you would write that code. You would write that code, and you would say the shape is, it looks like this, 2 eyes, nose a bit like this, and the mouth like this, and we should expect whiskers here. And so you describe that in code, and that has to be done, and you would not know whether that's going to give you accurate results until you keep on writing for each different case. So you now see a different cat. It has longer whiskers or smaller whiskers, or it might have slightly different eyes. Now you have to write for that circumstances as well. And then you keep on, now you have a cat which is slightly angled. It's looking different.
You literally have to program or code for each possible anomaly, or just each feature or what have you. So it's complex.
It's very complex. So,
and unwieldy.
Yeah, tedious. It's just tedious.
So are you saying that we, even with machine learning, we're still talking machine learning here, yeah?
No. So what I'm saying is that it's not possible using the traditional computer vision tools, but with machine learning, it becomes easier, because all we do is we say, here's a face. In fact, here are all the faces of a cat. And then we say that go and look at these faces and learn how they look like. And then we want you to build a recommendation system to let us know whether, if we give you a new image, is it a cat or is it a dog?
So what's happening in the background? Again, this is just my simplistic view on this. What's happening in the background is you write some basic rules into the machine learning engine. You then give it the source data, i.e. pictures of all the cats.
Yeah.
And if that source data is poisoned in any way, shape, or form, the machine learning algorithm will not produce the right results. You still have to give it relevant data. It couldn't just go off and do its own thing and figure its own thing out. You still have to have a human involved at some point to control that, or to at least let it learn, give it the information it needs to learn.
Yeah. So, for example, I'll give you a very simple example of how it does the recognition. Say you have a letter A, right? So we will start with, instead of cats, we'll go to something more simpler. Letter A, capital letter A, in an image, and you have, and that's all you have. So you have one box, white box, letter A, capital, and it's filling the whole box. And we would say that, we want to recognize this. First, we want to train it, and then we want to recognize this. So it would train it. It would basically say, okay, this is the letter A. The pixels are. It will turn the picture into pixel values in terms of the white spaces are 0 and the black spaces are 1. And then it would basically store, sort of, as in where the white spaces appear and where the black spaces appear. And it would store a sort of an image in terms of what it actually looks like in terms of when you draw. Yeah,
it'd store the vector essentially, not the, because a rasterization wouldn't really work very well in that instance.
So, and then all of a sudden, when you have a different shape, when you have a different image of letter A, but this time it's written with a different font, and it's still capital. We have to stick with that for now. So it's still capital. What it does is it's going to put the two images together, and it's going to do. It's going to try to take away. Yeah, it's going to try to take away one pixel value against the other. And it's going to see what the values are. Now, when it matches A with A, it's going to have a very high score. And when it matches A with B, it's not going to have a high score. So the way it does this recognition in terms of A and B.
But when it matches E with C, capital E with capital C, it's going to be very similar score, but lower than an A with an A.
There's correct me if I'm wrong, but when it comes,
thing.
Yeah, I was going to say it's definitely a probability thing. I mean, you're going to be getting a value or a statistical value, and I'm assuming it's up to the humans to set what the threshold would be, so you can prevent the false positives and the false negatives and things like that.
So the
idea is that.
Oops, sorry.
If you give it enough data.
No. We have been in.
Is that if you give it enough data?
Oh. We're losing Zain a little bit. Sorry, Zain, your internet went a bit funny then. Start again with the data.
Yes.
Yeah. So if you have enough data, it will, and yes, obviously it does depend on the algorithm as well. You would basically form a very high score of a particular letter. Now, if you're saying that it's not good enough or the threshold is not high enough, that obviously is a problem, and that's when you enter the problem of you are doing the machine learning engineering of how do you make sure you have the high score, you have the right score, and it recognizes that image well enough, but general enough that it'll work for all the cats, things like that. So that's then the engineering of how do you tweak the algorithm, what do you need to do, and how much data do you need to give, and what the data needs to look like. And do you need to, apply some functions to the data as well first, so that the data is different enough but still general enough, things like that.
Yeah.
Right.
So what the final output for the actual algorithm then? So does machine learning output an algorithm? And it may be a very complicated algorithm, but is that what it does? It eventually gives you, this is the algorithm to recognize a cat.
So it doesn't give you an algorithm. Because algorithm, it would be like a step-by-step method of doing something.
Yeah.
What it outputs, it's a bit of it's basically weights, or weights are exactly the variables when I explained. You have three different conditions, and you have a number attached in front of, say, 2 times likely to flood in this particular spot, and 3 times likely to flood in this particular spot, right? So these are the sort of 3 times or 2 times or 2.1. These are sort of weights or variable attached to a variable, a number attached to a variable. That's all a weight is. And what it does is it gives you the weights. Now the thing is that what it looks like and what it does, that's the actual black box. And how do we understand it? That's the actual black box. That's another question, I believe, in the. Is it worth going into right now?
Well, if you're naturally going towards it, why not?
Yeah.
It's quite interesting listening to just you monologue. We normally have a lot to say on these podcasts, but we aren't as educated in these issues. So
yeah, and the thing is, there needs to be a demystification here, because we hear in the IT industry a huge bunch of fantastic things like the black box or the algorithm or the thing. And you made a very valid point at the start. In the world of AI, there are a lot of different branches, and each one of those branches goes deeper. I mean, when you say that you're an IT professional, so many people assume you know how to fix their computer, when reality, one of the things that you're actually doing is robot building, which has nothing to do with PCs at all. But there are tons of branches. Just like when you say you're a doctor of what? Psychology, medicine, literature. There's so many branches. So understanding that sort of delineation and demystifying it is important. So in your case, you said that machine learning is really, you have your machine and you say, give it a whole bunch of pictures, makes a difference what the subject matter is or what the data set happens to be. It's learn this. This is what I want you to be able to recognize. And then that is the machine learning side of it. And you said that this has gained popularity over the other branches. That's kind of what I'm curious to learn about, is some of the other branches as well. Because I want to go back to what you mentioned. You said you would explain how they're separate. I want to know why the machine learning has taken the precedence over any other type of AI.
Can I hasten to guess as to why machine learning has taken over? It sounds to me, and again, I kind of knew this deep down, but it sounds to me like machine learning allows humans to produce really complicated results and really complicated outputs from huge amounts of data that would otherwise take a long time for a lot of humans to go through and output the same results for, because it can process that amount of data, because it's learning on the go. Basically, you give it 1 million images of cats and it can then identify any cat in the world at any angle.
So the thing is that actually I do have an opinion in terms of why why it has become famous. And that's basically based on the sort of books I've read of the recent AI history and what I've been trying to follow in terms of why this particular thing and why not other fields as well. So now I'm just thinking there are 2 things I'm trying to keep in mind of this, talking about black boxes and then talking about why AI, or why at least machine learning has become really famous. So I'll go with the idea why it has become really famous. The thing is that recently, or not so recently, back in late 1960s or early 1970s, there was, you probably are aware, have you guys heard of the book or read the book, The Man Who Solved the Market?
I've heard of it.
I've heard of it, but I've never read it.
So it's basically, that's the book you would in terms of AI history, or at least the modern AI history, where all the applications we have currently seem to be based on the work that was done by the people who are described in that book. So it's basically about a mathematician who goes and starts a hedge fund, or quite a few hedge funds, but let's just say one hedge fund. What he does is he basically believes that, we can solve the market. We can actually, in terms of beat the market and make a lot of money on the on Wall Street, New York, and we can do that by mathematics. Now, a lot of people, think that, and they try to start that as well. But he basically, did it. And the way he does it is that he basically first goes and obviously believes that it can be done, right? then he goes and hires a lot of mathematicians. He takes them from IBM. He takes them from all sorts of other top companies at that time, and universities and university departments. And he takes them, puts them in one room, and then he says, okay, we need to solve this problem. Now, the next thing is not that they solve the problem. The next thing is that they actually fail for 10 years or so. They keep on failing. They make money, they lose money. They make money, they lose money. Sometimes lose more money. And the person who launches, the mathematician, is Jim Simons. And he has other technological, you could say, startups as well.
Mm-hmm.
So he's making money from others, and he's still thinking whether it'll work or not. And so the whole sort of company, the whole hedge fund, the group of mathematicians, they fail for a very long time. But soon enough, because they have been in the game for such a long time, they do succeed. And then
they machine learned.
And they succeed. It's to such an extent that they make billions. Then they are successful, and no one has ever been successful in actually reproducing their results. So one of the things they did was they did that. They basically analyzed data from a very long time. So what they did was they analyzed data in terms of, say, we have a economic downturn. For example, we have coronavirus. The way they would analyze that is that how did something similar, an epidemic, affect the markets? So they would analyze. They would see how much data do we have? Do we have data from 1800s or further back? They would collect that data. They would put that into their algorithms, and they would see, how does that data, what does that data mean, and how do the markets react based on that event that happened in the past? Can we learn anything from it? And so that's the sort of thing they are doing. They're doing exactly what we would say today, the data science practice. So they were doing exactly all. You would read it and you were like thinking, well, that seems like a company doing that in 2019. But they were doing that.
We've had someone mention trading bots currently in chat as well.
So but that was being done back in 1980s when the whole world was thinking there was AI winter. There's no way you can actually use AI to do any practical thing other than probably OCR, which is still very limited. But they were doing very, very complex things, and they started to make money, and they obviously had enough money to invest in bigger machines and stuff. And then obviously the idea leaked into the market, and all of a sudden it seems that all the other companies are trying to replicate that, at least not only in the world of investing, but also in all the other technologies such as facial recognition and all the other things that we currently use AI for.
Is it safe to say then, in some time in the future, forgetting about the catastrophizing of AI, if we think about the actual practical use for that, if they can perfect an algorithm or a machine learning algorithm that tells them how the market's going to react to every potential situation that can occur, that means that at some point in the future, it may be decades, it may be hundreds of years in the future, they will be able to predict the outcome of almost any potential event, or not just on the markets, but on anything. They could essentially predict the future with AI to an extent.
So the answer is no, and
I have to jump in on this one. Do you know why I think the answer is no? Humans are messy.
Yes.
Yeah.
Okay. In the end,
Chaos
we are not perfectly ordered in any way. The fact that we even exist is a freak of nature. So, simply put, we are way too messy for pure prediction and, future craft. We're not going to have our little, 8 balls that we wake up in the morning and go, is today the day that I need to go into the office because something amazing will happen on the stock market? No, I'm going back to bed. Like, we're not capable of doing that. We're way too chaotic. That's why I think the answer is no.
The answer I actually got from that book. You'd be surprised. It's really amazing to know. So the thing is that the reason, or partly, or like a good chunk of the reason why they were successful was, yes, there is machine learning, and they are trying to predict the market, but market is very chaotic because not of there are humans in it, but because there are so many different kinds of branches within the market. For example, there's agriculture, there's computers, there are all sorts of different companies. There's oil, there's gas, there's everything that affects humanity is on the market, right?
There are new markets as well that come in as well.
They're emerging ones, absolutely.
So there's just so much in the market that it's simply impossible to predict it, even at that time, even right now. The only reason why they were successful is basically it's pretty simple. It's very interesting. They were able to find patterns in all the data they had from 1800s that humans, how they react to bad news is exactly the same.
Mm-hmm.
Basically, understanding human nature is a thing. Would you also say, though, because Voltrak from our chat brings up an interesting point, do you think that there's also limitation about that kind of predictability, a bit like weather? So we have massive systems that are constantly used to predict weather, but they're only accurate up to like 3 days before the entire prediction just kind of scatters and peters out. It's really hard to go past a certain, I'll call it singularity because we're talking about AI.
Yeah.
So, is it possible that that's also got an impact as to why it would be impossible to make that kind of future prediction? Or if there is, it would have to be really short term.
It appears that the way they would do that, for example, if we say take coronavirus, what they would try to do is say, you know what, we know coronavirus is affecting the markets, and they would know whether to buy or sell. Right now is the best time to buy because everything is cheap. And what they would do is they would basically look at the previous epidemic, which was as big, say the Spanish influenza, 1918. And they would look at how did that affect the markets, what happened, and how did the people or how humans reacted. Now, the reason why humans are predictable in this particular sense is that there are a lot of investors who are very emotional. And as soon as they see, the market is going down, they would sell.
So they're risk adverse. Very high risk adverse.
So it's basically how a lot of investors who are trying to make money, because they're quite small, they don't actually have, they're not Warren Buffett's. They don't know how they don't have the patience, whatever you may call it. But the thing is that it's simple that how they react to the market seems to affect the prices. Now they would take that. Now, another thing I just want to mention before, the answer to whether they will be able to predict a lot of the future events or not. So here's a quote I really have to read on this podcast from that book. So one of the guys who is one of the main mathematicians, who is now, say, the CTO of the company, but at least at the time in 19 or 2000 something, he basically is explaining the algorithm, right, to his clients, to billionaires who have a lot of money, who just want to give them all the money to increase. So he's saying that we are right 50.75% of the time. And then he says, but we are 100% right 50.75% of the time. And we can make billions this way. So they're only right. They have to. So the way they do it,
they push that margin just over, and that was just enough.
But they know that in order to keep consistent at 50.75, all they have to do is they have to make small bets or small investments, but a lot of them, ridiculous number of them, and they would know that in this huge distribution, we know that we will be right 50.75% of the time, and that's enough. So the machine is wrong so many times, almost 50%. Now the thing is that's quite interesting, that they are only able to beat the market at a very small margin, not even on 1%, but they're able to do that. They now know that they can do that, and that's enough to make billions for them.
Yeah.
So for us to think, for us to be scared, AI is going to take over. Look, it's making billions for a company, but you're like, they're only getting about 50, less than 50. About 50% of the decisions correct. And if it was 50%, they're right 50%. They'd be making zero money. They are making 50%, they're losing 50%. But that's the thing, which is that although, yes, they've had a huge success, and it is to do with machine learning as well. What I'm trying to say is not that they were very successful, they made billions, and everyone should be doing it. What I'm trying to make the point is that the practice of AI was used in investment for that particular purpose, and but they obviously had other tactics. They saw that they have to do certain things here and there to
Don't
make them.
put all your eggs in the AI basket and expect it to
Yeah.
handle all of the things for you, because AI is a tool just like anything else.
Yeah, that's it.
And
Yeah,
it should be part of your tool set, not the tool.
So we're coming towards the end of the show. So can we maybe cover on the black box stuff that we were referring to? So can you explain it to start off with?
Sure. So the black box is, as I explained, is basically you have a lot of weights, and so the idea of black box is AI will make a prediction, but you do not know why it made that prediction. That's why it's called a black box. And you're trying to find out how can you find out what the reason was. Now that's the impossible bit. The reason why it's impossible or why it's not relatable is that it does not have an equation or a few equations which solve or which let you know why it arrived at that decision. For example, if someone if you have a lot of data and you basically you put that into a machine learning model, and that data is for, say, used for knowing or implementing credit. So whether a person should be given a mortgage or not, that sort of usage. Now you are obviously putting that data in, and then you put this new file in, as in, should this person be given a mortgage or not? And the AI basically replies no. And then you have no reason, it doesn't give you a reason why. And you have no reason in the system to actually know what the reason is. Now that's black box.
Sounds like CEST. Sounds like the IR35 tool.
You know what? Do you know what it sounds like to me? And this is a severe abstraction to it. But it sounds to me almost as if the black box is the emotional core we humans have, because we can give you a reaction, but we can't always tell you why we're giving you the reaction that we're giving you.
Machines are not emotional.
Bringing up Scott, I know. I'm not saying it's the emotional cortex. I'm saying it is like that, because
this doesn't make any sense to me then. This doesn't make any sense that if a machine which works on zeros and ones and works on code and works on algorithms, no matter how it gets to creating this algorithm, there is a path that it takes down the code to get to an answer, a result. Why does this I don't fully understand.
That's a very good question, and that's the exact question that people have. And which has basically led people to solve it. So the good news is there is a white box.
A white box. Okay.
Excellent.
So the reason why I was leading up to that, I was explaining what the black box is. Now the thing is that people, and here's the thing, exactly what you mentioned, that it's a thing we programmed. How is it possible it can come up with something we don't understand? So
I can understand that we wouldn't understand it, but we should have the path to be able to understand it immediately. But to get to the point where we can look at it, analyze it, maybe spent 10 years looking at the reasons that it got to that point, because the tree structures that it would produce, I imagine, would be immeasurably complicated to get to some particular outcomes.
And by trees, for those who don't know, it's decision trees.
Yeah, so decisions that it makes to get to a point. Loads of if statements, loads of while loops, that kind of thing.
Or, we're denying you a mortgage because you happen to meet a certain threshold where we know people won't pay back their mortgage.
Yeah.
Or, something like they die before they can pay the mortgage back, or you just have a bad credit score.
Yeah. So the white box is basically it's quite, what's really nice before I go into the black box is obviously there are researchers who are trying to have algorithms or create algorithms on top of AI which can solve that issue, which can solve a black box and give us the reasons. And by reasons, it means give us an equation, which, we can take the numbers from the same data or a different data set, and it will give us the variables. I mentioned in the beginning that the actual variables for that for an equation. Now, and that's something which I was actually recently attending a talk in London, and that's something basically people are within the Alan Turing Institute and institutions connected to Alan Turing Institute. They are working on, and what they are doing is that they are basically looking at how can we create, and they have been successful at quite a few black boxes now, and I think it's probably a matter of time that it'll actually come to market, and you can actually use it for like a normal a commercial purpose. And what it does is it basically looks at the black box, and it then runs algorithms on top of the black box to understand the black box itself, because the black box, obviously, you just mentioned, is quite complex. It's going to have some sort of a tree, and then it basically creates an equation out of that. It will create a very complex equation, but once you have an equation, then you can simplify it in terms of, okay, you know what, we want something linear. We don't want to, and we are happy to lose the results. So things like that, it can actually do. It can actually work.
Yeah, see, I was just about to
Linear
say, I
model,
mean,
yeah.
the moment you have an equation, and that's generally what you're doing with machine learning, is you're trying to develop some kind of equation to solve a problem, whatever that problem may be. But once you have an equation and you put it out there are a lot of things that can be done with it. Like at what point do you no longer need that black box because you have your equation? There's something to be said for the demystification that is brilliant, but also, should we fear that our black box overlords are going to rise up and come at us because we're taking their jobs away,
Not in
giving
this
them
instance.
to humans? I am being incredibly sarcastic here.
But there is a real worry about AI in the more general sense, as we talked about right at the beginning. But in this instance, absolutely not, because it's under so many constraints and has so limited data. It might have lots and lots of data, but it's lots of very specific data. As we said, it's scoped to the exact problem that that's trying to solve.
I was trying to be really silly and funny.
I understand that, Josey. I'm trying to explain to people that this is why AI, that in its current form, is not really a problem.
Don't worry about Skynet, folks. Seriously,
Yeah.
Don't worry about it.
So the thing is that why do we need a black box? The thing is that actually the algorithms we have currently they only work off a black box. So you do need to get to a black box and need to have a sophisticated, good, well, not a good black box in the sense that it's giving you a very high level of accuracy of prediction. And once you have that, then the algorithm basically works off that black box and then tries to understand it. It's not possible that the algorithm is going to try and work off the data and get rid of the black box. It's just not possible. The other thing is that in terms of whether we should be worried of, whether AI or whether AI would be worried, the thing is that currently AI, even say the self-driving cars is very limited, and that's one of the biggest issues of the engineers working at self-driving cars companies. So Tesla, Uber, and all these companies, the biggest issue they're facing is that it simply cannot generalize enough. It will only be limited to the data we give it. How can we give it less data and it needs to generalize like a human? That
it can only generate algorithms that you give it data for and give it parameters for. And also not just the data and the parameters, it's that you have to actually give it that initial, this is kind of how you need to perform, this is how you need to do it, this is how you need to determine if there's I've when we've been talking, I've actually thought of two particular instances where last year I was involved with AI related work. One was, I can't go into too much detail because most of it's NDA, but one was a machine learning algorithm that I was desperately trying to stay away from because it was a load of statisticians and mathematicians and academics that I was well out of my depth with, but I knew system architecture and I was trying to design the software systems for the algorithms to feed into. And another one was, I can't really tell you much more about that. It's extremely kind of NDA, so I can't even tell you the kind of work it was. But the other one was self-driving cars. It was essentially in big cities where I was actually directly involved in working with aggregate data on edge and fog networks, where we pulled in data from. I was working on some proof of concepts for a new piece of technology that was being put into a rather large enterprise system, and it was working with billions of lines of data coming in, over a period of like 100 seconds or something, and it had to aggregate that data, and I was using proprietary edge hardware and some edge kind of software and messaging systems, and designing the architecture around it, and dealing with that data, aggregating it, and figuring out basically when to apply the brakes on the car, and luckily I wasn't involved in the production side, because God knows how much insurance I'd need for that kind of thing. But the company that I was working for directly involved in that, and it's really interesting to look at it that way. That's big data. That's data that's almost discardable, to a point. It needs to be logged, but apart from that, it's
a fascinating topic, although I will state we are pretty much towards the end of our show.
We are.
So is there any last thoughts you want to say? Zain, you're going to be back. Obviously, this is a topic that is fascinating, not just for, the debunking and the demystification, but in the practical applications. I don't think people realize how impacted they are by these black boxes and these machine learning platforms and AI in general. So, you'll be back, but is there any last, say, one thing you might want to say to sort of help sum up any points you might have wanted to get across just today?
So, actually, we talked a lot about AI. I think the last point would be something very interesting. I would say that although, AI is great. However, there are a lot of companies out there who are thinking, do we need AI? Maybe we just throw AI at it and it'll solve and stuff, things like that. But from my experience, most of the problems in the industry or in the commercial world can be solved without AI, can be solved with simple but very good software techniques. And that's something where you have to really understand, it's not an AI problem. And the first thing you should always do is look at, can we solve this without AI? And then try to go towards that. And if not, then obviously you do need AI, then you basically go into the AI route.
However, I can hear a lot of marketers going, but we want to be able to tag AI. We're AI people. We're selling our products because we have AI features. I could just hear marketing people crying. But yes, we are at the end of our show. I am getting a tiny little bit of feedback, so I'm going to pull back just a little bit, just in case. But we're at the end of our show. Massive thank you to all of you in Twitch chat for joining us. Thank you for everyone in the future who's listening to the podcast. Finally, Zain, thank you so much for joining us. We hope you've enjoyed your show and your time here. And before we let you go, I want you to pimp yourself in any projects you want, but I also want you to share something that you may have learned this week. A little bring your own manual to the rest of the world.
In terms of pimp myself, I would say I am a data strategy consultant. So I'm basically... so that's the sort of work I do in terms of analyzing whether do we need data, do we need AI to solve a problem, and if we do, then how do we solve that? So and I basically help companies within that sphere of how can we use data before we bring in AI. How can we use that data to actually make money and to solve business problems? So that's the sort of work I do. You can check out my LinkedIn and Twitter. So yeah, that's about it. In terms of learning, I would say I'm not sure. I think I would say actually there are a lot of simple AI tools out there which are accessible with APIs. So all you have to do is basically sign up to the APIs, and you can most of the simple stuff. If you're say Chris, if you're working on a customer wants some simple OCR, but a good OCR, or they just want to be able to scan an image and know whether this image contains digits or what digits there are, read the image, that sort of simple stuff. There are APIs for that, and for example, Google Cloud API or even Azure APIs, Azure Vision API, I think, and they are very powerful for most of the needs, for most of the things you could think of.
I had my wife and I had a discussion a few years ago, and it probably exists somewhere. I think Hulu have implemented it actually, if not other like Netflix and other kind of streaming services have done it now. We wanted to be able to pause a TV program or pause the TV at any moment and immediately see the IMDb images IMDb profiles for all of the people that are on the screen. I bet that already exists, but if it doesn't,
It does.
all right, okay.
It does. Amazon Prime actually, or Amazon itself, I believe has, I think it's called like X-ray or something else like that. But if you pause the screen, whatever actors are actually known in that scene itself, there is a lot or like a column on the left-hand side or something like that that puts the name, a picture, and gives you a quick link, or it says also known for or has been in, and
But
you can actually dig
I'm-
deeper by just clicking a link and going.
I'm
in
assuming that essentially has to be AI in order to do that, because there's so much
there's
video
no
content
way for
out
hand.
Yeah.
There's no way to hand.
You
do
couldn't
it.
you couldn't manually go for when you could, but you'd leave with
Well,
a lot of people to
It's
manually
quite
go
simple. Yeah,
So that was something that I wanted to put together a while back, and there was a few other little things.
It
that
already
I had an idea
exists,
for, but it
Chris,
already
it's
exists.
great.
I missed the
It
boat on
does
it.
indeed. Okay, what about you, Chris? Anything you learned this week?
Oh, so yes, I didn't learn it this week because this week I have not really. I've been doing a lot of scripting and I'm still doing this migration, so I'm doing a lot of things that I already knew. But a few weeks ago, I learned about Git repositories. I learned something I didn't know, at least intrinsically, about Git repositories. I'd heard the term a bare Git repository before. Have you both heard of the term bare Git repository?
no.
As in
No.
B-A-R-E. So a bare Git repository. If you've worked with Git, there is a .git folder within your Git repository, and that contains all of your metadata for the repository and all of the objects and all of the references and all of the heads, and it controls the repository locally and remotely. Now, a bare Git repository is that folder, but you can instantiate a bare Git repository from any other repository, and you don't get a working copy because Git does not. And I knew this anyway, this part anyway, but I didn't know where the bare Git repository sat. I didn't know how they actually worked or why they existed. So when you create a bare repository, that you cannot work in it, you can't push to it, you can't set remotes, you can set remotes, but you can't do anything with the files because the files don't exist, because Git does not hold a copy of the working folder. Git holds a copy of the entire history, and it builds up using trees, using I forgot the name, I forgot the exact name of it, but it builds up the files in your working folder when you check out from a remote repository from the history. And it sounds a bit odd, but that's why Git is so quick, because it doesn't hold a copy of the files. It holds a reference to any file that's in the repository, in the actual bare repository. So most things like GitHub, Azure DevOps, anything that has Bitbucket, etc., they are bare Git repositories. When you check them out, you can either check the bare out, or you can check out the working copy, which is the general git clone command that we run when we do a clone, and it creates essentially on your local machine the repository as it sits. So you imagine a really complicated repository. It's really quite interesting. And I also learned another thing about that today as well, where it was actually today. I didn't realize, but if you had two, let's say, binary files or two text files that are exact copies of each other within the same Git repository that have the same SHA commit, they essentially just reference the same object. You can copy the same file 5,000 times within the same Git repository if you really wanted to, and it would only store it once, and it would just store a reference to it everywhere else. So there you go. Bit of Git history, bit of Git interesting.
That is absolutely fascinating. And we actually kind of got 2 for 1 with you today, Chris.
Well, yeah, 2 Git things, but the thing that I learned today, which I didn't get onto until just then, was the icon thing. So if you had an icon or you had an exe or something like that, or even a text file, I think, if they've never changed and you've kept a direct reference to that file, it just references the file. But the other stuff I kind of knew from a while back. But yes, so. It's interesting, the inner workings of Git.
Yeah, and in my particular case, for those of you who are into IT automation in some way, shape, or form, or who are interested in learning a bit more about Ansible, there is a particular writer with Ansible called Jeff Geerling. And due to everything that's happening, and we hope you all and your family, your friends, and your coworkers, and everyone are being as safe as you can during this pandemic. But throughout April, his DevOps books are free. So if you want to learn more about Ansible, or you want to understand a little bit how to make automation work for you in the IT world, his books are free, and I will have the link for you in our show notes. But if you just head over to jeffgeerling.com, that's JEFFGEERLING.com, you can read his little post about how his books are being made free thanks to Device 42. But if you want to either learn, brush up, or whatever, I believe he works for Red Hat too. So, getting it from, so they say, from the mouth.
Oh,
Is
Red Hat,
a
the
thing.
worst Linux distribution.
It depends on who you ask.
Only because it turned commercial, and then the Linux community went, no.
Yeah, but you know that Ansible is part of Red Hat, right?
Is it? No, I didn't know. I haven't used Ansible
Well, I think
myself.
I believe Ansible is actually owned by Red Hat.
Okay.
That's a thing. Yeah, if you actually go check up on Ansible and stuff. But the thing is, it's about automation and stuff. But his DevOps book specific are free. So if it's something that interests you and you want to get into, I highly recommend it. Plus, I believe during this quarantine time, he is also doing a lot of live streams on YouTube to introduce the topic and to educate. So, you can also jump into
Volstrat has
things
just
like
linked
that.
it in chat as well, so I'll
Yeah, there you go. The chat is present there, and that is indeed it.
pop
And
it
it
up
is in
just so
our
people on
it'll be
video
in our
can see.
show notes, etc. too. But yes, we are literally now at the very, very, very end of our show.
We are.
And go for it, Chris. It's all on you, because I did it all backwards today.
You did. It's time for us to do our pimpage now. So you can visit our website at www.dnistream.live. You can find links to all our podcasts, all of our pod channels, or whatever you call them, all you kids, and all our discovery links for Discord. Sorry, lost Josey then.
Pod channels.
Discord,
Wow.
YouTube, everything else, all of our social medias on there. You can use it to contact us as well. We can definitely confirm that the contact form is working now, because we got some spam this week from somebody who wanted to sell us some services. It was a real person, though, because we've got capture on there. And you can use it to get in touch with if you want to be a guest on the show, you've got any comments, you've got any suggestions, or you just want to send us a nice message and tell us and set some fireworks off or something. Lots of fireworks going on outside. Is this a celebrate the NHS thing?
It's still a continuation of the celebration of the NHS. So 8 p.m. here in the United Kingdom, you'll sometimes get people putting off fireworks or cheering loudly in the street or something in celebration of all of our frontline healthcare workers.
Indeed. And lastly, please do not forget to follow us on Twitch above. Click follow if you haven't followed us already, and you'll get notified when we go live with our development streams, which we do at least once a week, or our podcast, which we do Thursday night, as you know if you're watching live.
Yes, and we hope to see you all next week on Thursday, 7 p.m. UK time, or if you want to join us for actual live stream coding, Wednesdays from 1 to 4 p.m. UK time at twitch.tv/DNIstream. And remember, if you like what we're doing, spread the love. And if you actually have an opinion on a topic in the world of IT and development, get in touch. Come on the show. Let's talk. As you can see, sometimes Chris and I are perfectly okay not knowing everything. Right? Chris, perfect?
Yes. The thing is, when I don't know something, I really want to go off. After this show, I've got in my mind now, well, I want to go out and I do a little AI project, because I'm really quite excited about it. I like learning about new things. But the thing is, practically, I have no bloody time to do that. I have no time unless I've got a very specific use case for something, and I want, I want to learn a new framework, or I want to learn AI, or I want to figure out something in Azure that's come out new. I just don't have the time, and I really wish I did. But
we definitely all need more time. But yes, all that's left is from us here, documentation not included, to say goodbye, and we'll see you next week. So goodbye, Chris.
Goodbye.
Goodbye, Zain.
Goodbye.
And goodbye from Josey. We'll see you all next week.
Bye.
Bye-bye.